All right. You're given a positive integer of exactly 4 digits. Split that number into 2 new integers. And by using the digits found in the original number, leading zeros are allowed in the new numbers, and all the digits found in the number must be used. For example, given a number 2932, I'm sorry, excuse me, you have the following digits: 2 2s, 1 9, and 1 3. Some of the possible pairs are 22 and 93, 23 and 92, 2 2 3 and 9, 2 and 3 2 9. Return the minimum possible sum of new 1 and new 2. Minimum possible sum. So the lowest possible number of two numbers made of the first number. This is not a difficult problem in terms of programming it, and it's really not a difficult problem, I think, in any way. But how would we know what rules will lead us to the lowest possible sum? Anybody have an idea? You can either speak up or put it in the chat. Any ideas? So this is the first question I asked myself when I looked at this problem. Can a 3-digit number ever get us to the lowest possible sum? And we can look at a range of numbers here. Let's look at this one first. So I could make this number and I would get 112. But if I split it in 2, I would get 22. So there's no way that 3 digits here is ever going to get us a lower number. And of course, if there's no 3-digit, then there's no 1-digit. So there's only 2 digits and 2 digits. But let's try some more. How about 4171? All right, well, the lowest 3-digit number I could make would be 114. And then I would add 7 to that, and that would be 121. Or I could make, even if I don't even, if I just like make my highest numbers, 71 and 41 get me to, what is that? 112. I think I did that right, yeah. 112. So my highest possible 2-digit numbers are still lower than my lowest possible 3-digit numbers. So the first thing I'm going to do is just eliminate any chance that a 3-digit number is a relevant answer. What about, I don't know, maybe you say, well, what about, Jordan, what about 1,000? Couldn't I do 0, 0, 0 plus 1? Yes, but you could also do 0, 0 plus 0, 1. And what do you know? It's the same. So in our best case scenario, it's the same as splitting this into 2 digits. So we're going to say here, the answer to this is no. So I don't even have to consider 1-digit and 3-digit numbers. Just going to delete all of that. Now, the next question I ask myself is, how would I order my 2-digit numbers to get the lowest possible single number? So before I even worry about adding them together, how would I order them to get a low number? So looking at, here's an example, 4589. The lowest number I can get is 4, 5. And then the next lowest number would be 8, 9. Okay, but can I do any better to make 2 low numbers? So to make a single low number, it looks like how I order them is I put the lower number before the higher number. But I need to make 2 numbers. So I just want to put my 2 lowest numbers and then my next 2 lowest numbers, 48, 59. And with that, I think I have my idea about how to solve this problem. So here we have 90 plus 17. So this is equal to 107. And can I pull out a lower number from here? Almost anything else I could do, I don't know, 4, 9 plus 5, 8. But you know what? That is the same total. 107. So yes, I could switch those second numbers, but it doesn't change. And of course, that's the same thing as switching the first numbers, but it doesn't change. So then I landed on pretty quickly a rule that said, take the two lowest numbers, then take the next two lowest numbers, then add. Okay, so we have a number here, but we need to get all of the digits out of it. There's a couple ways we can do that. My preferred way, that's pretty simple, is just like let digits equal string of num dot split each one, and then sort it. That's going to give us all of the numbers from least to greatest. Then I'm really just going to do return my first number, remember, is my lowest number. So I'm going to say I want a number. That number is made up of digit at 0. That's my lowest number. Plus digits at 2. That's my, not my next lowest number, but the one after that. And then I want to add this to number at digits at 1. That's my second lowest number, plus digits at 3. That's my highest number. Let's just walk ourselves through that and see how that would work. So again, given this example of 4, 5, 8, 9, the first thing we do is turn it into a string. That's what this part does. The next thing we do is split it. So that makes an array of 4, 5, 8, 9. Then we sort it. I'm just going to drop this down to the next line. This one already happens to be sorted, actually, so nothing changes there. Okay, then we return number with what? With a string of 4, that's at the 0 index, plus a string of 8. Now, mind you, those are not adding together like 12, right? When we add two strings together, they concatenate themselves. So we have that 48, and now it evaluates to a number. So it's going to be 48 plus the same thing over here. And that's going to be a string of 5 plus a string of 9. Of course, we concatenate those and we end up with 59. Then we cast it to a number and we end up with 59. And then we add them together and we're going to get 107. And there is our answer. So let me comment out all of this. Now, we haven't used LeetCode that much in this class. On LeetCode, you do not have, unfortunately, the same robust testing environment as you do on CodeWars. So I open up my console here. Here is a test case. I'm just going to use the one I just used there, 4, 5, 8, 9 for right now. We run our code. Clicking on run code here is the same as clicking on test in CodeWars. And we see, yes, 4, 5, 8, 9 was the input. Our output is 107 and the expected output is 107. One thing I do like about LeetCode is they basically run your input on their code as well, and they'll tell you if you're wrong. Whereas CodeWars won't do that. Honestly, it's better the way CodeWars does it. That's much more like real world training, but at least we can appreciate that they have this. All right, let's go with 3471. And just sketching this out real quick, following our rules, it would be 1, 4 plus 3, 7. So we got 40, 51 is our expected answer here. Go ahead and run that. And we see, yep, our code is returning 51 and the expected answer is 51. With that, we'll clean up. Okay, you can look for some efficiency here and say, I'm casting, I'm splitting, and I'm sorting. The time complexity of this is n log n, where n is the number of digits. So if we want to evaluate this, we say it's 4 times log 4. Okay, we now have to evaluate this before we can say what 4 times that is going to be. Log 4 Does anybody know what log means? I don't think we've talked about this in this class. How many times do I cut this in half before I reach 1? So log n here is how many times do we cut 4 in half? We cut it 1 time in half when we get 2. So that's 1, and then we cut it 1 time in half again and we get 1. So log n here is equal to 2. And so our runtime is 4 times 8, or 4 times 2, which gives us 8. And the reason that this is important in this particular case is because we know that our number is never going to be more than 4 digits. So while this looks, I think, kind of inefficient, given that we're working on such a tiny, tiny input, it hardly matters what we do here. Anyways, I don't think it's a big deal. Otherwise, we can certainly maybe change it if we had such a much longer number or something like that. But the time complexity here is all coming from sort, which is n log n, which is why that is happening. And if we want to evaluate exactly what it is for this number, it's just 4. I'm sorry, it's just 8. All right, and this is all 1 here, right? We're just reaching out for exact digits, converting them to a number, adding them together. This is not a complex thing, only this. All right, let's go ahead and submit that. And there we go. I tend to disregard these. They fluctuate so wildly, even with the same code. Even if we like submit this again, we'll see much different numbers here. So I don't think you should give too much weight to this feature of LeetCode, but otherwise, some fun little exercises in here. And some of these, of course, start off like this one, quite easy. You notice it's much harder to do test-driven development here. I forget if we can we do this? I don't think so, though. I don't think you can run two inputs. Cool if you can, though. Oh, you can. That's great. I'm not sure you could always do that, but that's a lot better. So now you can more properly do test-driven development here. Still not as good as Code Wars, but better.